Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters. So I'm going to show you the problem in three ways, that is in three parts. So let's get going. We are going to see the first part now. Solve y double dash plus y equal to cosecant x cot x or d square plus 1 into y equal to cosecant x cot x using variation of parameters. So we are given a differential equation of order 2. Given differential equation y double dash plus y equal to cosecant x into cot x. We know that y double dash is double derivative of y, right? So we can write y double dash as d square y by dx square plus y equal to cosecant x into cot x. Now we can write d square y by dx square in differential operator form, that is d square y plus y equal to cosecant x into cot x. Now take y common from these two terms, we'll get d square plus 1 into y equal to cosecant x cot x. Consider the given differential equation as 1 and the equation in operator form, say f of d into y equal to some r of x be some equation 2. Okay, now the homogeneous equation of 2 is d square plus 1 into y equal to 0, right? And also by comparing these two equations we'll get f of d, where f of d is d square plus 1. Now we'll find the solution of homogeneous equation. Consider this equation of as equation 3. Now we'll find the solution of this equation 3 using auxiliary equation, and later we'll find equation solution or general solution of equation 2 using the solution of equation 3. Okay. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d square plus 1. Let's replace differential operator by m, so that we'll get f of m equal to m square plus 1. Now the auxiliary equation becomes m square plus 1 equals to 0, then m square equals to minus 1, then m equal to plus or minus square root of minus 1. Since square root of minus 1 is I, so let's replace square root of minus 1 with I, we'll get plus or minus I. Therefore, m equal to plus or minus I. The roots are complex conjugate. We know that when m equal to a plus or minus I b are the roots of an auxiliary equation, then the solution of homogeneous equation will be y equal to e power ax into some constant into cos bx plus another constant into sin bx. So when a equals to 0, we'll get e power 0 into x, right? E power 0 into x is e power 0 of c3 cos bx plus c4 sin bx. Since e power 0 equals to 1, so you'll get 1 into c3 cos bx plus c4 sin bx, which is equals to c3 cos bx plus c4 sin bx, right? Now let's write the equation, solution of equation 3. The solution of homogeneous equation 3 is y equal to, just compare plus or minus I with plus or minus IB, then for b equal to 1 you'll get C3 cos 1 into x plus C4 sin 1 into x. Then y equal to C3 cos x plus C4 sin x is the solution of the homogeneous equation, right? Let y equal to, now replace C3, C4 by some functions of x. Okay, now we are going to replace these constants or parameters with functions of x, a and b. We'll get a cos x plus b sin x. Let y equal to a cos x plus b sin x be the general solution of equation 1. Okay, equation 1 or equation 2. Where a and b are functions of x. Okay, now we'll find y dash and y double dash. We have y equal to a cos x plus b sin x, right? Let's find y double dash. Y dash and y double dash, okay? First we will find y dash, that is derivative of y with respect to x. We'll get a cos x whole dash plus b sin x whole dash. Here we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u. So for u equal to a and v equal to cos x, a cos x whole dash becomes a dash into cos x plus a into derivative of cos x with respect to x plus b dash sin x plus b into derivative of sin x with respect to x. This equals to a dash cos x plus a into derivative of cos x with respect to x is minus sin x plus b dash sin x plus b into derivative of sin x is cos x. This becomes a dash cos x minus plus into minus a sin x plus b dash sin x plus b cos x. Let's now write the terms involving a and b. We'll get minus a sin x plus b cos x. Now write the terms involving a dash and b dash. We'll get plus a dash cos x plus b dash sin x. Now let a dash cos x plus b dash sin x is 0. Let a dash cos x plus b dash sin x equals to 0. Consider it as equation 4. So that while finding y double dash, a double dash and b double dash will not appear. Okay, then y becomes minus a sin x plus b cos x plus 0, right? This becomes minus a sin x plus, it's y dash, right, cos x. Now we got y dash and already we are having y. Let's now find y double dash, that is derivative of y dash with respect to x. Now we are having y dash. Let's now find y double dash equals to minus of a sin x whole dash plus b cos x whole dash. Here also we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u. This is equals to minus of a dash into sin x plus a into derivative of sin x with respect to x plus b dash cos x plus b into derivative of cos x with respect to x. This is equals to minus of a dash sin x plus a into derivative of sin x with respect to x is cos x plus b dash cos x plus b into derivative of cos x with respect to x is minus sin x. This becomes minus of a dash sin x plus a cos x plus b dash cos x plus into minus minus b sin x, right? This is equals to minus a dash sin x minus into plus minus a cos x plus b dash cos x minus b sin x. So we got y double dash now, right? Y double dash equals to minus a dash sin x minus a cos x plus b dash cos x minus b sin x. Now we are having y double dash and y dash and y double dash. Okay. Now what we are going to do is we are going to use equation 1 and we'll substitute y dash and y in this equation 1. We have equation 1, y double dash plus y equals to cosecant x into cot x. Now substitute y double dash in equation 1. Okay, 1 becomes y double dash is minus a dash sin x minus a cos x plus b dash cos x minus b sin x plus y a cos x plus b sin x equal to cosecant x into cot x. This becomes minus a dash sin x minus a cos x plus b dash cos x minus b sin x plus a cos x plus b sin x equal to cosecant x into cot x, right? So here minus a cos x plus a cos x gets cancelled, minus b sin x plus b sin x gets cancelled, and the equation reduces to minus a dash sin x plus b dash cos x equal to cosecant x cot x. Consider it as equation number 5. Now we'll solve equation 4 and 5 to find a dash and b dash. Now we need to solve these two equations, right? So observe the first terms. In the first term we are having a dash cos x, a dash sin x, okay, minus a dash sin x, right? So in order to cancel these two terms, we need a sin x in this and a cos x in this, right? So let's multiply equation 4 with sin x and equation 5 with cos x. Now solving equation 4 and 5. A dash cos x into sin x cos x plus b dash sin x into sin x is sin square x equal to 0. Now multiply this equation with cos x, we'll get minus a dash sin x cos x plus b dash cos x into cos x is cos square x equal to cosecant x cot x into cos x, right? So here plus a dash sin x cos x and minus a dash sin x cos x gets cancelled, and we'll get b dash sin square x plus b dash cos square x equals to cosecant x cot x into cos x. Now take b dash common from these two terms, we'll get b dash of sin square x plus cos square x equals to, we can write cosecant theta as reciprocal of sin theta and cot theta as cos theta by sin theta. Now let's replace cosecant x as 1 by or with 1 by sin x and replace cot x with cos x by sin x into cos x, right? Since we know that sin square theta plus cos square theta equal to 1, the above equation becomes b dash into 1 equal to cos x into cos x, or you can write it as cos x into cos x by sin x into sin x. From this we'll get b dash equals to cos square x by sin x into sin x, sin square x, right? Or cos x by sin x whole square. Since we know that cos theta by sin theta is cot theta, so you'll get cot x whole square or cot square x. So we got b dash. Therefore, b dash equals to cot square x. Now we got b dash. Let's substitute b dash in equation 4 so that we'll get a dash. We have equation 4. A dash cos x plus b dash sin x equals to 0. Now take this term to RHS, we'll get a dash cos x equals to minus b dash sin x, then a dash equals to minus b dash into sin x by cos x. Now substitute b dash equals to cot square x, or since b dash equals to cot square x, then a dash equals to minus of cot square x into sin x by cos x, or okay, right, sin x by cos x as tan x, right, is equals to minus. We know that cot theta equals to reciprocal of tan theta, right? Then cot square theta equals to 1 by tan square theta, right? So we can write cot square x as 1 by tan square x. So if we cancel 1 tan square x, we'll get minus 1 by tan x again. 1 by tan theta is cot theta, so we can write 1 by tan x as cot x. Okay, therefore a dash equals to minus cot x. We got a dash and b dash. Let's find a and b using a dash and b dash. So firstly, I'll begin with a dash. We have a dash equals to minus cot x, right? A dash is nothing but derivative of a with respect to x equals to minus cot x. Now let's separate the variables. In order to separate the variables, we'll take the differential dx to RHS, then we'll get dA equal to minus cot x into dx. So here the variables are separable. So we can perform integration. Integral dA equal to minus integral cot x dx, right? Since we know that integral d theta equal to theta and integral cot theta d theta equal to log mod sin theta, or if you are not good at remembering formula, we can just find integral d theta, cot theta d theta, since cot theta is cos theta by sin theta, right? If f of x equals to sin theta, f of theta equal to sin theta, then f dash of theta is derivative of sin theta with respect to theta is cos theta, right? Since we know that integral f dash of theta by f of theta d theta equal to log mod f of theta, right? Here the integrand is of the form f dash of theta by f of theta, right, which is in this form. So we can write it as log mod sin theta using this formula, okay, or log sin theta. Now this becomes integral dA a equal to minus integral cot x dx is log sin x plus some integral constant, say c1. So we got a from a dash equals to minus cot x. Let's find b from b dash equals to cot square x. We know that cosecant square x minus cot square x equals to 1. Right? Now, we can write it as 1 minus cosecant square x minus 1 equal to cosecant square x minus cot x. Right? Now, bring this minus cot square x to LHS and take this 1 to RHS. We'll get cot square x equals to cosecant square x minus 1. Right? Since cot square x equals to cosecant square x minus 1, so the above equation becomes b dash equals to cosecant square x minus 1. Right? Why we have changed cot square x to cosecant square x minus 1 is we can write this b dash as derivative of b with respect to x. In the next step we have to integrate, right? Or we can write b dash as derivative of b with respect to x equal to just write as it is cot square x. Now separate the variables by taking differential dx to RHS. We'll get db equal to cot square x dx, where the variables are separable. Now we can perform integration. We'll get integral db equal to integral cos square x dx. Okay. Now we are free to replace cot square x with cosecant square x minus 1. Let's replace it. Okay. We'll get cosecant square x minus 1 into dx. This becomes integral db equal to integral cosecant square x dx minus integral dx. Since we know that integral d theta equal to theta and integral cosecant square theta equal to minus cot theta. So from this we'll get integral db b equal to integral cosecant square x is minus cot x minus integral dx is x plus integral constant, say some c2. So we got b, therefore b equal to minus cot x minus x plus c2. Now we are having a and b, right? We got a and b, so we can write the general solution using this formula. Therefore, the general solution of equation 1 or equation 2 is given by y equal to a cos x plus b sin x. Then y equal to, we have a minus log sin x plus c1 into cos x plus b minus cot x minus x plus c2 into sin x. Right? This equals to minus cos x into log sin x is minus cos x log sin x plus c1 cos x plus into minus minus cot x into sin x minus into plus minus x into sin x is x sin x plus c2 sin x. Right? This equals to minus cos x log sin x plus c1 cos x. Now we can take sin x common from these two terms or minus sin x common from these two terms. We'll get minus of cot x plus x into sin x plus c2 sin x. This becomes, now write the terms involving c1 and c2 firstly. We'll get c1 cos x plus c2 sin x minus cos x log sin x minus of cot x plus x into sin x. Therefore, y equal to C1 cos x plus C2 sin x minus cos x into log sin x minus of cot x plus x into sin x is the required solution. So we have seen a problem from variation of parameters in this video. So we have completed part 1 and remaining part 2 and part 3 will be seen in the next 2 videos. I hope you will understand. We'll see you in the next video. Until then, bye bye.